very much for inviting me to this seminar. As you noticed, I have a little bit changed my title. I'm now more concentrating on these measures in agriculture at present, which is almost my main presentation, but I will say something about what happens in the future. Of course, it's a storyline of Baltic Compass project and partly our work package group, so it's not any structured scenario. And part of this at the future, of course, are these river basin management plans, because they have made for each of the river basin districts, and there actually people who have been doing them are saying how many this and this type of measures are needed for certain areas. And in Finland we have 8 river basin districts, and I have been looking these plans from all of these districts, and I have noticed that very often the measures are very similar, despite of the fact that the catchments may differ and even the soils may differ in the area. So the measures are actually quite same. And during the morning hours it was interesting to hear, for instance, Peter told us that you have seen in these small catchments that something has happened when you have applied a lot of measures. In Finland, our case is that we have noticed, of course, at the field plot scale, and in some cases in a small scale where there is mostly agricultural area, and the measures have been implemented quite wide. But in many other river basins, we haven't noticed yet anything. Even if there have been a lot of measures applied in Finland, and according to our modeling results, there should be reduction for agricultural measures. But before I go to the measures, I was asked to say something about the Finnish agricultural scenarios, and I have collected something. Of course, these are kind of basic information that in Finnish area, the winter zone crops will have a greater extent in the future than they now have, and because of this effective growing season, temperature is increasing, it will increase also the yields. So these are the basic things. And over there, these data is more available if you look at this reference. This is the newest climate change project in Finland called Ilmasopu, and they have been producing a lot of material what happens to Finnish agriculture. And in some of these reports they are saying, like I noticed that Peter was saying, that in the medium term perspective, CAP, so Common Agricultural Policy, and it measures has the main effect. But maybe in the long run, the climate change related impacts can become more important. We don't know, but this is what is expected. So you can collect data in different types, and not only modeling, not collecting the measured data at the outlet of the river basin or at the field plot level, but you can also interview people, how they think that the future looks like. And this is a publication made by my colleague from SYKE, Minna Kaljonen, and what was his name firstly? Pasi Rikkonen from MTT, Agro-Food Research Center. And they were interviewing farmers and experts, what they think that the future look like. And I have picked up here some of the parts of this interview. And if the number is close to -2, it means substantial decrease. If it's 2, it's increase. If it's zero, almost nothing happens. And here, as you can see, which was already mentioned here in the meeting, that size of the farm and number of the animals per farm will increase in the future, both according to farmers and experts. But the total cultivated arable area is decreasing a little bit according to this analysis, and I think this was the same for the scenario runs that Henrik Eckersten have been done for Finland. The area was slightly decreasing. And then, surprisingly, demand for domestic food products is increasing, total milk production decreasing, importance of agriculture in rural development is decreasing, and share of agricultural subsidies in farmers' income. According to farmers, they are afraid that it will decrease, but experts are a little bit more positive. But this type of information is also available. It's not structured scenario making, but it gives you some idea what these people who are now working on these fields think that the future looks like.
What time horizon on the future? What time horizon?
I think it was up to 2020.
Yeah.
Yeah. So not so far away. So now I come more closely to my main topic. In Baltic Compass project, this work package 3, where Eva is working, sitting somewhere there, they have been giving us the top 5 list of measures now used in Baltic Sea region. And these are the top 5 measures. It's vegetative cover in autumn and winter, avoiding the spreading of chemical fertilizers and manure during high-risk periods, and also avoiding to spread them to high-risk areas. Storage of manures has been considered a very important measure, and also buffer zones, preventing erosion. So these are now, at present, the most used method in Baltic Sea region. And I would say that some of these measures may even in the near future be the most popular ones, because some of these have not been applied at that wide and extensively that they should be used. In the project, we started to analyze which measures we are able to model with our models. And we made this list. This is only part of the list that can we model this one or can we not. And as you can see, this first one, long-term grass cultivation, vegetative cover in winter, autumn and winter, yes, we can model soil tillage. If it's reduced soil tillage, time of the year effect, yes. Fertilizer, we can model the effect of using fertilizers. But in many countries, this data is not available at the level that would be needed. So I mean, for instance, farm level. In Finland, we can get it at the municipality level. So not very detailed data. So we don't know how much one individual farmer is fertilizing and where he's putting manure. This information is not available in Finland. So very often we are lacking the data to test the efficiency of the measures. Especially if it's some new measure, there are not so much data available. And some of these measures, as I already said, can be are mostly from field level. Maybe wetlands you can measure, because you can measure the concentration on the water above and below the wetland. So you can really know what is the efficiency of the wetland. But these are based on very few field experiments made in Finland. And then, as the first speaker in the morning was stressing, I'm also uncertain how well our process descriptions are in the models, because I have noticed that some of the descriptions might be even wrong if you really go into the code and look at this one. So this type of information we have made. In this my presentation I will give you examples of two models from Finland which we have been using. And this Vihma model, it's not a physical-based model. We have been collecting data, agricultural data, on field experiments where they have been measuring the efficiency of buffer zones, vegetation cover, with the paired field plots. And then they have got some specific loading values for certain type of field plots. So inside this model we have, let's say, hundreds of different types of field plots, and we have been estimating the specific loading based on the data available, and then we have also data from the efficiency of the measure. So this is not a physically based model. It doesn't use meteorological data to give you some daily variability, but it should give you some information what is the efficiency of the method at the long run. And even if we don't have this climate data, we have separated this database to years which represent average year or a wet year or mild year, when the loading is different from that one when you, for instance, have a spring melting period and nothing else. So there might be continuous melting periods throughout the winter. And with this model, we have a possibility to analyze what is the situation now, how much does the river basin management plan influence, how much retention we can get, and then we have made some scenarios of a current and this river basin management plan, that if we add still something more, in this case the three steeper field slopes have been changed in the way that we are growing grass or put wintertime stubble, or what is the other one? Okay. This river basin management plans, if there is still place to do this for this type of data. And here you can see the data for a medium winter, and as you can see the current level is around 32,000 kilos per year, and this is the situation in these warm years. And of course, if you apply these measures, you don't even receive that level when the year happens to be a wet year. So there's a difference where you really analyze it. The other model we have been using in Finland is this SWAT model. It's made in US, and it is actually nowadays used in quite many countries. And in this model, you have an ability to model quite many different water protection measures. But of course you need a lot of data that you really can say that your model is working. But basically you can model these agricultural management practices, cultivation practices, whatever, fertilization, subsurface drainage, buffer zones, ponds, etc., wetlands also. And we have been running this model on, to some selected catchment. And I want to show you an example of wetland. Wetland is not so popular measure nowadays around the Baltic Sea countries. Maybe in Sweden and Finland, Denmark also a little bit you are applying wetlands, but not so much in Baltic countries or Poland. And when we first made, this is made now with this SWAT model, and we put these 10 then already existing wetlands into our model and tested what is the efficiency at the outlet of this big river basin, not in a small one. And we noticed that it's nothing. These 10 wetlands affected not at all to the water quality at the river outlet. Okay, then we added some new wetlands. For each sub-basin we put almost 30 wetlands, and the area, combined area, came up to 7.5 hectares. And then the reduction was 4%. So not very much. It is beyond the limits of your accuracy of the model in any case. And the second scenario was that we put even more wetlands, but now we also changed the size of the wetland, because in Finland, by monitoring, we have noticed that if the size of the wetland compared to the size of the watershed above, if it's high enough, it has more space to be effective, to retain nutrients. And this is one of the key factors that when you build up a wetland, you should keep in mind, because most of these wetlands are very small ones. And in the case of using this type of wetlands, the retention percent is almost nothing. When a big flood comes, everything goes through. Okay, this is the first exercise. I always like to put this triangle when I show model results, because I think that people should know there's a lot of uncertainty when you give modeling results. So you have to think by yourself, is this realistic or not one? I don't have the triangles in my other figures, but keep it in mind. I mean the next ones. So this is the same type of example about these constructed wetlands in Aurajoki River Basin. It's a basin that is directly flowing into the Baltic Sea, and quite high, almost 40% of the area is agricultural land. So in Finnish standards, this is very high number. And here we have done a similar type of exercise, adding these wetlands. And as you can see from these reduction of loading percents, they are very, very low. So wetlands might be a good additive measure, but it doesn't solve your problems if you don't build up them enormously. In Finland, we have been estimating that there are potential places more than 45,000 for wetlands, but so far, let's say 350 has been built. And in River Basin Management Plan, there is a plan to build 1,700 wetlands by 2015 or 16. So not very much, and the efficiency is not that good. But of course, wetlands has other advantages too. So the biodiversity of the area might increase. So it's multifunctional wetland. So we have been applying these process-based models only for some selected sites or basins in Finland. But in Finland we are also using this so-called watershed simulation system that is working all over the Finnish country. And because this is already automatically calibrated for discharge to all of these basins in Finland, we have now, during the recent years, tried to put these more process-based models into this system, because that way we could run more catchments, get more data. But of course, there should be also people testing how correct these data are. If you have 8,000 third-level water catchments, then you should look each of them how well your model is working, even if it's automatically calibrated. But this is the model run made with this watershed simulation system, and now phosphorus load is in question, and these are monthly values. The black line is describing the discharge now, and these colored lines are how it looks in the future. 2070 or 80 is the last one. So, as you can see, this peak will go to the earlier months, starting maybe from November up to January, February. So more flow peaks, not only one peak during the winter. So this is what will change. And this is definitely producing you higher phosphorus load. But here only climate is included in this figure. So in the next figure, in this one, we have been running this ice cream field plot model implemented into this watershed system, and we have tried to look what happens if we make some changes in the input. And in this case, we have less arable land, we have more grass instead of cereals, and we have also decrease in soil phosphorus status. Because nowadays in Finland the average value is about 13 milligrams per liter, but in the future we are hoping to get it close 7-8. And this optimistic view has been included into the model. And then, of course, the model shows, for many reasons, that the phosphorus load will be decreasing. But I'm not sure if this happens. But this includes both the climate change and also the land use changes. But very often there is something in the model that we haven't yet checked, because these are the new model runs. Okay? And this figure, with this figure I try to show you what maybe all of you who has been using models know this one, that there is a lot of uncertainties in modeling, and there's a lot of uncertainties in the climate change input, in scenarios, in land use, and also in temperature and precipitation. There are some average figures that you are producing. And then, which also the first speaker was talking about, I'm not really sure that our process descriptions for these water protection measures are really correct ones. Maybe they are too simple ones, even with these river basin models. And because of this data lack, we are not really able to test our models, how well they work. So this is one thing that you should keep in mind. And then I want to go to this, one of my favorite things, because nowadays we have been starting to measure the concentration, the water quality, with these automatic continuous data devices. And with this you can nowadays measure nitrate and turbidity. Also there are phosphate trials. Barbara, I know that you have been now testing these devices. And turbidity is a very good measure to actually get also sediments, and then in a case if you have, for instance, mineral clay soil, the correlation between turbidity and total phosphorus is rather good. So with these measurements, this is the data taken from one of our wetlands. Blue one is the inflow and the red one is the outflow. So in this case you really can see how your wetland is working. How much comes in, how much goes out. And I think this type of data will help us really to say something how effective these measures are, and maybe also help you to give better understanding of the transport processes, what happens there, if our equations in the models are not correct ones. So I was a little bit wondering, it's a good sign that you in Sweden have now noticed that the trends are going down in the small catchments. And because in Finland we haven't yet seen this one, even if in some of our basin we are using these continuous measurements, so we get quite correctly what is the load from this area, or what is the, let's say, what is the nitrate concentration in the area. There's still a lot of variability, and in Finland, even if the models show that the measures have some efficiency, we haven't yet seen it really from the riverine outlet data. There's some indication in the Botnian Bay area that the phosphorus is increasing, but in some cases nitrogen decreasing phosphorus, but the nitrogen is increasing. And we are now thinking about what is the reason for this one. And just recently, because somebody was talking the data around the whole Baltic Sea region, there's a lot of inaccuracies in the data. I was just with my colleague Seppo Nuuttila in Luga River. He was arrested because he really wanted to know what is the level of phosphate in this river. So the values given to HELCOM might not be that correct that we are believing. So, how many minutes I have? Okay, this is my last figure. So, agricultural measures in the future. I don't know how they look like. But I have been thinking, and some of the Baltic Compass partners too, what measures might be used in the future. Because I think there is still a lot of place for the traditional measures. Even then they are not implied at the wide range that they should be implied. But I have been thinking that more chemical treatments might be used, for instance connected to wetlands, to ditches. I don't know how it will happen, but we know that the efficiency is much better. For instance, in Finland we have been applying calcium sulfate in some of the coastal areas, and according to the first monitoring measurements, it's much better than buffer zones. But nobody is using it. It's a new measure, maybe too little scientific background to say that this is a good measure, and Yara is selling the calcium sulfate, so maybe farmers are not interested to buy it. I don't know what is the main reason. And then I'm also believing that processing of manure to different fractions and might help you to really put the fertilizer in a place where it is really needed and not all places evenly. So this is my point, that new technique might give in the future more answers for reduction of nutrients. And also use of nitrification inhibitors might be one of these measures that could be used. In Germany, they have started to use these algae bonds, so they recycle waters and use these special harvesting measures. So I don't know how much recycling is used in general in Baltic countries, but for instance in these wetlands in Finland, we are recycling the drainage waters into the wetland, just to give also to them the opportunity to little bit get better when they flow out. So this was my main message, and this I would like to say a last one, because during the past 20-30 years we have tried to make water flowing faster. We have made drain tubes and drainages so good that everything goes immediately. But I would like to introduce, or many of our colleagues, to slowing down the water flow. Somehow, what measures could be used to this one? So then they might have a possibility to retain more efficiently and maybe then used by vegetation. So slow water. Thank you very much.